So, my name is Gabriele Pesce, and I will moderate today's discussion, as you can guess. And I work for Euratom Power, the European Association of District Heating and Cooling. First of all, I'd like to thank you for being here. I'm glad to say that all the district heating community and beyond always takes part with a good number of participants. And I'd like also to add that I'm particularly happy as Italian to have a completely Italian panel. Of course, not for nationalistic reason, but in reality, let's say for too long, fossil fuels played and still play a fundamental role in the energy sector in Italy. And the possibility to present two great examples of the efforts that are being made by an Italian association, an Italian company towards decarbonization makes me very proud. In fact, today's topic is very important. Heating accounts for almost 50% of all emission in Europe, and its decarbonization is the true pillar to meet the 2050s goal. Despite the COVID-19 pandemics, once all these will finally come to an end, I see that we will rediscover that the real emergency concerns climate. Fortunately, the European Union is fully committed on the path to energy transition and the reduction of the polluting emission, and in particular in the energy sector, is still a priority. The new Green Deal and the whole regulatory framework is being set up right now, such as the renovation way, the sector integration strategy, the sustainable finance strategy, and the upcoming revision of the REED directive and the EED directive regulation is pointing to the right direction. The heating sector is on the front line on this transition on both policy and technological side. During this webinar, for example, with the help of our experts, we will get an overview of the decarbonization challenges and the possible solutions that, such as low carbon heat innovation, sector coupling, integration of renewable in the modern district heating networks. After presentation of a very interesting overview of some of the most recent technological solutions around Europe made by Turboden, we will get a very inspiring study on the potential of district heating in Italy. As I said, policy and technology, in particular in the heating sector, have inextricably linked one another. A favorable policy framework supports the implementation and the development of innovative projects. At the same time, best practices, good example in innovation foster the evolution of policy, highlighting how solutions exist and should be supported. So, okay, I already talked too much. I would like to give the floor to the first panelist, Andrea Magalini, Sales Director of Turboden, part of the Mitsubishi Heavy Industry Group. So, Andrea, it's a pleasure to give you the floor. Please.
Thank you, Gabriele. Unfortunately, I don't know why my team is playing tricks on us today. So I was saying that I would like to present the point of view of a technology provider, and I was just jumping into the topic. As I said, the energy sector in Europe is rapidly changing, and not only in Europe, as I was mentioning. And this change is happening due to many factors and some trends that are ongoing. Can you go to the next, please? Next, please, Gabriela. Okay, and this is not an exhaustive presentation of what is going on, but it's just mentioning some ideas that pumped up in my mind while I was thinking about this topic. We are seeing megatrends, and one of the megatrends is decarbonization that Gabriele already spoke about during the introduction, and the push to sustainability. Please, next, Gabriele. Generation, in terms of generation and power and heat, is also changing dramatically. In the last 20 years, we saw more and more renewables entering into the production stage, and we see more and more interest in energy efficiency. And lastly, we are all seeing how the electrification of heat will evolve, which is also another hot topic, as Gabriele was mentioning, also at the regulatory level. Can you go to the next, please? Technology is also changing dramatically because technology must be developed in order to accommodate the new needs and the new challenges in the energy sector. So we are seeing new technologies for renewables, of course, as I mentioned, but also smart grids. Now we are all talking about hydrogen as a possible future fuel, which will lead us to a zero carbon society. Can you go to the next, please? We are also looking at changes in business models, for example, which are now different from what we had in the past. We have energy performance contracts that are more and more common in the industry, with ESCO companies playing an important role. We are seeing synthetic PPAs. There is the emission trading system that is making energy efficiency attractive or needed in some cases. Next, please. And we are seeing also changes in finance and the way of funding projects around Europe. The European Green Deal is a big opportunity to receive funding from the European Union, but also finance in general is changing in the energy sector. More and more funds and financial institutions are deciding to invest in the green economy, and so also in the green generation of power and heat. And also the latest technologies like blockchain, fintech in general, are taking a role also in energy, for example, with the tokenization of real assets related to the production of electricity or heat. Can you go to the next one, please? In all this context, which is complicated, all these factors are some way interrelated. We, as a technology provider, see the technological innovation as a key enabler of all what is happening, so of this revolution in essence. Can you go to the next, please? And this situation is opening up huge opportunities for all the stakeholders in the sector, for the producers of energy, for the users, on the other hand, who are receiving more competitive energy in terms of cost, but also additional benefits in terms of sustainability of the electricity and heat they are using, and also for the providers of technology. Going directly into one of the topics of my presentation, I want just to mention that if we look only at the potential market for large heat pumps, we see an addressable potential of 25 gigawatts, so 25,000 megawatts thermal of installable equipment, which is a huge amount only related to Europe. Can you go to the next one, please? And as you can see, this potential is spread across many countries in Europe. There is a very interesting potential in Germany, but also Italy, Sweden, France, Finland, Austria, and Denmark, and then Portugal and Switzerland will be interested by the adoption of this new technology as a way to produce clean heat. And the interesting point is that as of today, we see that only 5% of this important market is already exploited. And so this is just an example of how a new technology can respond to a need, the need to produce clean heat, and how many things we still have to do in the sector. Next one, please. Just a few words about who we are. Turboden is an Italian company, but it's a group company of Mitsubishi Heavy Industries from Japan. And 2020 is our 40th birthday. And this company has been always focused on the development of a single technology, which is the organic ranking cycle system that I will touch base upon later, which is a type of generation system for electricity and heat very suitable for distributed generation, which is also another trend that I didn't mention before, which is getting more and more importance in the latest years. In addition to the organic ranking cycle, we recently started in the last 3-4 years to develop other products, including the large heat pumps that I mentioned before, and also the gas expanders that I will mention at the end of the presentation. Next, please. Please, next. Thank you. So a few words about the organic ranking cycle. The organic ranking cycle system is basically a turbo generator where a ranking cycle is implemented, but instead of using water, which is the typical means adopted for the ranking cycles, we are using different. Specifically, we are using organic fluids, for example, hydrocarbons or refrigerants. The interesting point of this system is that it's very flexible and can provide some advantages as compared to the traditional ranking technology running on steam. One of the key points is that it can be used to recover heat also at low temperature, which is not possible with other technologies. In terms of size, as I said, these systems are very suitable for distributed generation, so the size is fairly small. Our units are typically in the range from a few hundred kilowatts up to 40 megawatts per single unit, which is starting to be quite large, actually. Next, please. Large heat pumps. This is another technology that we are now proposing to the market, and it's a natural evolution of what we have been doing for the last 40 years, because if you look at the technology of a large heat pump, it is a kind of organic Rankine cycle reversed, where instead of a turbine expanding a fluid, you have a compressor compressing a fluid, and the fluids are similar. And the heat pumps can be used to lift heat from a low-grade source to a higher-grade user, and the users can be typically district heating networks or industrial processes by means of exploitation of electrical power. So if you have clean electrical power coming from renewables, for example, you can use this basically to generate clean heat. Typical sizes that we are proposing are in the range of from 2 to 30 megawatt thermal, which is a very big heat pump, with high lift, where the lift is the difference between the cold source that you have available and the heat user temperature, which can be even higher than 100 degrees C. Next, please. Our newborn product is the gas expanders, and this is a system to enhance the efficiency of gas distribution networks. And basically, it can be used to expand the methane gas in the pressure letdown stations in the gas distribution networks or at industrial sites. And this allows basically to exploit energy that otherwise would be wasted, dissipated in form of heat. And the typical size is from a few hundred kilowatts, which is very common size for this system in the gas distribution networks, up to a few megawatts. Next, please. Okay, starting from the organic Rankine cycle, as I said, this is a very flexible technology. If you look at the left, you see that it can be basically used irrespective of the heat source that you have available. So it can be combustion of biomass, combustion of waste, or heat recovery from heat streams that are not exploited in industrial processes, including oil and gas, for example. It can be geothermal, where you need to be able to recover heat at lower temperature, or it can be even combustion of other fuels like methane, like gas. And we are proposing a specific ORC system to allow cogeneration at high temperature with the production of steam. As output, you can have different type of outputs. You can just produce electricity. You can work in cogeneration mode, producing electricity and heat, which can be then sent to the different type of users in form of water, hot water, or in form of steam. But you can even use the system to generate mechanical energy in the form, for example, of compressed air, which is also an application that we installed in some industrial sites, or, and this is some new feature of the system, you can even think about using the system to run an electrolyzer to produce hydrogen, which may be a new frontier that will develop more in the future. Next, please. Just to give you an idea, there are many ORC systems deployed around the world. This is just a snapshot of the Turboden fleet. We have most of our plants are running in biomass, so there is combustion of biomass with an ORC recovering the heat from the combustion. We have like 450 megawatts installed. Most of those are in Europe, actually. Then we have geothermal, which is also a quite interesting application where you can just generate electricity or do cogeneration, as it happens in Germany, for example. We have a waste heat recovery plant, roughly a bit less than 100 megawatts in industrial processes, including oil and gas. We have a couple of high temperature cogeneration systems already deployed, and then all the other applications. Overall, we have roughly 400 plants around the world, and we produced, this is just an indication, roughly 22,000 gigawatt hours of clean electricity. So we are some way contributing to the decarbonization of the world with our technology. Can you go to the next one, please? Okay, just some examples, mainly related to district heatings. Next one, please. First example is about Bavaria, so the southern region of Germany, where we have a number of plants. We have 21 plants which are connected to district heatings, and most of those plants are biomass plants. And some of those are actually, as you can see on the left of the slide, geothermal plants. We have 4 geothermal plants that are generating power and heat, and they are connected to the local grid for the electricity and to the local district heating for the heat. And then we have 2 plants just producing electricity. Average size of the plants is in the range of 4 or 5 megawatts. Overall, we produce 25 megawatts thermal with geothermal source and 27 megawatts electricity. And most of these plants are owned by the local utilities. And as you can see on the right, there are many plants deployed around the region. And I think this is a very interesting example of integration of electricity and heat using new and clean technologies to provide electricity and heat to the local communities. Okay, can you go to the next one, please? This is another example of an interesting application, which in my opinion will become more and more popular in the future in Europe, but also outside Europe. On the left, you see one of our references, which is basically an ORC unit producing 1 megawatts, roughly 1.2, from the recovering of heat coming from the combustion of dried sludge, which is taken from a water treatment system, wastewater treatment system. And this is an interesting way to increase the efficiency of this type of installations, the water treatment systems, producing some electricity by using a residue, the dried sludge. On the right, we see another example. This is not a reference, but just a case study, where instead of using an ORC to produce electricity, we are thinking about exploiting the residual heat coming out from the water treatment system with a heat pump in order to lift the heat and feed a district heating network. Actually, this is not a new idea. There are a number of plants like this deployed around Europe. We saw statistics where we say that there are 54 plants producing 900 megawatts thermal. And I think that also this may become a trend in the future, because it's a very good idea to exploit this waste heat in order to produce usable heat for the local communities by means of a very efficient system as the large heat pump. Next one, please. Okay, this is another example of organic ranking cycle system integrated with the district heating network. This is a waste incinerator burning municipal solid waste in Belgium. And this incinerator was meant to produce heat to feed the local district heating. As you can see here, there are some users indicated in the picture. In parallel to the district heating, which was already in operation, we were asked by the owner of the incinerator to install an ORC system, which is recovering since almost 10 years ago, excess heat in the district heating. So when the load of the district heating is lower and excess heat is available from the operation of the incinerator, our ORC system recovers this heat in order to produce some electricity. And here we are working at high temperature for district heating because it's 180 degrees C, but a low temperature for heat recovery, which is possible only thanks to the characteristics of the ORC system. Next one, please. Just to give an overall idea of how cogeneration with serving district heating is spread in Europe, we put this chart where we show how our plants are distributed in the different countries. We see that we have a lot of plants in Germany and Italy, a good number in Austria, then we have UK, Poland, Latvia, and this is not exhaustive. We have also plants in the other countries. Overall, we have 274 CHP plants, 97% of those are fed by biomass, and we are producing over 1.2 gigawatts thermal, of which roughly 700 are delivered to local district heatings. And in addition to that, we are producing 300 megawatts of electricity. electricity. So I think that Europe is already on the right path towards decarbonization, and all the examples that I'm giving, I think, are good examples that could be even further replicated. Let's go to the next one, please, Gabriele. Here we have a couple of examples of installations. This is a biomass plant. This is in northern Italy on the border with Austria, in Dobbiaco. This plant is producing 1.5 megawatts and 8 megawatts thermal, which are sent to the local district heating. It's an interesting example of a circular economy because the wood is taken from in the local area, from the surrounding woods. It's burned to produce electricity and heat, which basically is used by the local communities. And these are relatively small district heating serving the local villages in the Alps area. So I think it's a quite interesting example that can be easily replicated also because it's very sustainable. And this plant has been successfully operating for 15 years. So it's a very long-lasting plant, which is still working and still providing benefits. Next one, please. Okay, some other examples. These are very similar to the one that I mentioned before. These are 3 plants in Lombardy, our region, owned by A2A, which is the company of Mr. Spadoni that will speak after me. And we have three ORC biomass plants that are serving the local district heatings and are producing 1 megawatts of electricity each, very similar to the one that I mentioned before. Just to add additional examples of let's say, good working plans. Can we go to the next one, please, Gabriele? Okay, this is also another type of application that I think can be very interesting for the future decarbonization of heat and power in Europe. Here we are speaking about the steel sector. So speaking about a steelmaking company which is located in Italy, in Brescia, our hometown, where the company wanted to exploit the excess heat they had, let's say the waste heat they had. So first we started working with them, this is 4 or 5 years ago, and the company called Ori Martin, they decided to install a heat recovery system recovering the heat from the fumes of an electric arc furnace. This heat is then conveyed to the local district heating network, which is also here owned by A2A. And when there is excess heat, because the demand of the district heating is lower than the full load, the excess heat is sent to an ORC system, an organic Rankine cycle system, which is producing electricity, 2.2 megawatts. So I think this is a very interesting example of a, let's say, heavy CO2 emissions company like a steelmaking company of what they can do in order to become more sustainable and give benefits to the surrounding communities. It's interesting to say that this same company is now thinking about implementing a new project where instead of an ORC to produce electricity, they want to use a large heat pump to exploit some residual lower temperature heat around 50-60 degrees C they have coming out from their process. And this heat pump will lift the heat in order to feed the same district heating network that is already served by the heat recovery system that I mentioned before. And this project is about to start. It is funded by one of the programs of the European Union. And I think it will be a very good example to be replicated also in other industrial settings across Europe. This is a quite interesting heat pump. It's innovative because it can arrive to high temperature. It can reach 120 degrees C in order to feed the district heating when this temperature is required. And the size is about 6 megawatts thermal. Can you go to the next one, please, Gabriele? Okay, a few notes about heat pumps. I think we believe that our systems are very attractive for this type of installations because they are very efficient. We do an optimal design of the COP. They are large scale, as I already mentioned. They can provide high lift, as I already mentioned, and they can give high temperature output, which is a very interesting feature because it's what basically is needed for a high temperature user users like industrial processes. And we are speaking about temperatures we can go up to 200 degrees C. And in our opinion, it is clear that heat pumps will play a pivotal role in the future for the decarbonization of heat because it's one of the few systems that you can use to produce clean heat and by reducing the overall CO2 footprint, exploiting clean electricity. Can you go to the next one, please? Okay, this is the general concept of the heat pumps. As you can see on the left, there is a list of possible sources of heat that you can use. We have what we call the free sources, like wastewater, for example, or let's say river water. We have also some sources of heat that we call income generators, because this is heat, for example, in the industrial processes that needs to be cooled down, spending resources, spending money, spending electricity. Instead of cooling it down by cooling towers, for example, you can use a heat pump to cool them down. And you can have the same heat pump giving heat at a higher level of temperature to some users, which can be, for example, district heating networks. Next one, please. Okay, this is an example taken from Germany. An example of a heat pump which is designed to exploit a geothermal resource at 40 degrees C, as you can see on the bottom left of the chart. And it's aimed at giving 90 degrees C water to the local district heating network. In this case, we are thinking about integrating the heat pump with the cogeneration gas engine. So this will be at the end an hybrid system burning natural gas, but also using a natural resource like geothermal. And this type of setting makes sense in case the electricity is still has a still too high cost in order to make the business case of the heat pump successful. Coupling the heat pump with the gas engine, given that you're using gas instead of electricity to run the heat pump, the business case can become interesting. And if you look at it by energetic standpoint, you see that you are basically taking 95 units of heat coming from geothermal plus 100 units coming from the natural gas, and you are producing 180 units for the district heating, meaning that the 95 units that you got from geothermal transform in basically at the end 80 additional units in addition to what you are producing with gas, but at a higher temperature. So this is, let's say, more valuable heat. Next one, please. Next one, please, Gabriele.
Yeah, sorry, we had a problem. Yeah. Andrea, Lorenzo is arrived, so I can kindly ask you to speed up a little bit so
yes,
you
sure.
can have time for his presentation.
I think we have a couple of minutes more.
Yeah. Is it the right slide, sorry, Andrea?
No, next one, please.
Okay. Can you see it?
Not yet.
Oh, sorry. Yeah, today is very unlucky. Just a second. Okay.
Okay, just to conclude on, if you go, okay, go to the previous one, please. Previous.
Okay.
Okay, just quickly to conclude on the heat pumps, I wanted just to propose a couple of examples of applications in the industrial sectors. On the top, we have a plastic making industry where the heat pump basically is using heat that is coming at 85 degrees C from the process and is lifting up the heat to be used again from the process in form of steam. And at the bottom, you see another example. This is another chemical industry in Finland where they are thinking about using 80 degrees C water coming out from the process and lift it up to 110 to provide heat to the surrounding other industrial users. We can go to the next one. This is just to say that heat pumps can have many applications in many industrial sectors. I already mentioned some, and you can see in these slides other mentions, but it's not exhaustive. We range from food and beverage to greenhouses to pulp and paper, iron, as I mentioned, wastewater, textile, and also others. Next one, please. This is our last slides presenting our latest technology, which is the gas expander. Just to say that we have one gas expander under construction, the one that you can see on the left, producing more than 1 megawatt, and this is exploiting the pressure drop in pressure letdown stations in gas distribution networks. And we are also working on many other projects around Europe to propose even smaller gas expanders to exploit the same pressure drop both in gas distribution networks and also in pressure letdown stations at industrial user site. This is also, I think, a good technology to enhance the efficiency of our networks, and specifically in this case of the gas distribution networks. Next one, please. So I'm done with my presentation. I'm sorry if it took a bit too long. Just to conclude, as a technology provider, we want to just renew our commitment to provide more and more cutting-edge technologies to the market in order to enable this green revolution toward a decarbonized and more sustainable world. Thanks again for your attention, and I leave the floor to Gabriele and Mr. Spadoni.
Okay. Thank you, Andrea. It was a really a very interesting presentation. You gave us a very inspiring, I would say, overview of the latest innovation that we can have from the supply side for district heating and so on. I know that we have some questions, but I would like to give the floor immediately to the second panelist. Don't worry, you will have the opportunity to pose your question at the end of the second presentation, also for Turbonen and Lorenzo Spadoni. So I would like to kindly ask Lorenzo Spadoni, the president of the AIRU, so the Italian Association of Urban Heating, to switch on his camera. I think it should be connected. Lorenzo?
Yes, Gabriele, okay. Thank you. I am connected. I hope you can hear me.
I can hear very well. Welcome again. We know that he had a professional impediment, but he managed to be here fortunately. So he's going to present us a very interesting presentation about the potential of the district heating in Italy, a study made by the Politecnico di Milano and Politecnico di Torino, if I'm not wrong. So I would immediately give the floor to Lorenzo, and yes, enjoy this presentation. Please, Lorenzo.
Okay, thank you. I hope you can see my presentation.
Absolutely, absolutely.
Okay, very good, very good. Thank you. And okay, I would like to talk to you about the perspective of the AC in Italy, and in particular about the results of the joint potential study that our association has committed to the Polytechnic of Milan and Polytechnic of Turin. But let me spend a few words about just to present our association, AIRU. AIRU is a no-profit organization, was established in 1982 with a mission of promoting the AC and of the dissemination of innovation, renewable energies and energy efficiency culture. Our members are multi-utilities, let's say district heating operators, but also industrial partners, universities, municipalities, and also private citizens. We represent all the world of district heating in Italy. So what we deal with, you know very well, we deal with heating and cooling sector. It's not a very green sector. It's a very fossil based, but it is a very energy demanding, very energy demanding sector. Is responsible of half of primary energy consumption in the EU. And 70% of this demand is satisfied by fossil fuels still today, and 80% of this demand is coming from cities. So we have a very important opportunity to improve the heating and cooling of our cities. And what we propose for this? We propose efficient district heating. So sorry, I received a message that someone is not able to see the presentation, but
I can see your presentation, Lorenzo.
Okay.
I don't know if someone else is not seeing the presentation. Please write it in the chat. Okay. I don't know why today it's really unfortunate. Let's try to Okay, a lot of people cannot see the presentation. I don't know
Okay.
why I can't see it. Yeah, can you try to interrupt the sharing and re-sharing again?
Yes, I try.
Okay.
Okay.
Otherwise, I will do the same for as for.
Okay. Now it's coming.
It's coming.
Yeah.
I can see the presentation. Okay, I'm getting some message. Okay.
Okay, I come back to the point. Okay.
Okay.
So,
okay. Great.
What we propose to improve heating sector in our cities, of course, we propose efficient district heating and cooling. The district heating based on waste heat, on renewables of high efficiency CHP, which makes use of heat storages and also of digitalizations of the operation. This is what we propose, and this is the today dimension of the district heating sector in Italy. You can see the distribution of the networks. We have more than 300 networks, but most of them are very small networks, sometimes concentrated in the mountain regions, in the Alps, as you can see. But we have also three quite big systems in the city of Turin, Milan, and Brescia. We reached an estimation 1.3 million of flats, and we represent 3% of the total heat demand of a country. You see that for historical and also climate reason, most of the system are concentrated in the northern region. We delivered 9.3 terawatt-hour of heat every year, and we could generate 6 terawatt-hour of electricity from CHP plants, and we save 1.7 million tons of CO2 per year. This is the key figure today. But we are a little bit worried about the development of the future development. Here you can see the historical development of the AC in Italy, starting from 1972. It seems quite a quick increasing, but if you see to the last 4 or 5 years, you can see that the increasing year by year is slowing down, and so the sector is slowing down. So the question that we have is if there is a future for the AC in Italy, and what could be this future. And also, I come back to this slide. One could ask why we are slowing down. And the reason is that if you see this slowing down, and in the same time you see to the recent legislative development in Italy, you can find that there are in recent years several modifications of rules that have been not improving the DAC development and the realization of investments in the AC, and that is the main point that we are arising to the attention of our policy makers. And so to contribute to arise the debate around the future of district heating in Italy, we asked to the Politecnico of Milan and the Politecnico of Turin, which are the two main technical universities in Italy to make an evaluation of increasing potential of the AC on all the country, especially of the AC based on the use of waste heat and renewable. And they did it, and they started from the heat demand estimation and from the geographical reference mapping of the heat demand. In the same time, they made the estimation and the mapping of waste heat sources and of renewable heat sources available on the country, and they matched these two information to calculate the potential, and they matched also both from a point of view of technical feasibility, but also from the point of view of economical feasibility. The idea is that we can talk about a minimum cost scenario, which means that they calculate the district heating that can be realized at a cost which is equivalent to for the customer to the cost of possible alternatives. So made a sophisticated simulation to calculate the cost of distribution networks and all of the other costs involved in district heating realization, and they compare this cost with the cost of possible alternatives for the customers in every single piece of ground of the mapping. They have a collaboration also with Halmstad University and from the guys of the Heat Roadmap Europe project. So the results is that we have around something more than 300 terawatt-hour of heat demand in Italy for heating and cooling purposes. We have something more than 140 terawatt-hour that could be feasible, which are for which we have a technical feasibility, and 38 terawatt-hour in the minimum cost scenario. 38 terawatt-hour is more than 4 times the today dimension of the district heating sector in Italy. So it is, from our point of view, a quite huge potential, and probably this figure is a little bit underestimated due to some hypotheses that the universities made in their calculation, just to be on the safe side. But it is a very huge potential, which can contribute to increase to 5.7 megaton per year the CO2 saving, and that could also contribute to air quality improvement, especially in the northern plan, and the effect is equivalent to eliminate from the circulation 4 million of cars. So this is a huge point. So there is a potential, but at the same time, you see that the sector is slowing down. So why the sector is slowing down the speed of development, and at the same time we have a huge potential? The point is that to deploy this potential, we need to invest and to make great investments in infrastructures. We need to expand the networks, and the payback time of this investment is quite long. So we need some conditions for this. First of all, we need a stable policy condition. We need that the DAC must be fully included in the energy planning at the national and local level. And these two conditions have not been realized in recent years, and this is the main problem that we have. Of course, we also need to increase the awareness of citizens about this kind of solution, which is about the AC, which is a simple solution, a sustainable solution. And the awareness of citizens has to be increased in this sense. Also, we need rules and support schemes which are consistent with the decarbonization environmental targets, and they need that they have to be quickly established. In recent years, we see that support schemes were not consistent or coherent with the decarbonization targets. We see that we have in Italy support schemes for fossil technologies, like, for example, condensing boilers, and not for district heating. This is a distortion that has to be removed, a market distortion that has to be removed. And very important, these rules must be maintained in the long term, because the payback time of this investment is long. So we are talking and we are pushing to our policymakers in order to push for the establishment of these rules, and to the establishment of a coherent policy about district heating. And we hope that the results of this study could help in our policymakers in taking decision, fact-based decisions. So I can stop here for the moment, and if you have, if there are some questions, or I am available. Thank you.
Thank you, Lorenzo. I think talking about the potential district heating in Italy, it's always very, very important. We are a big market that with an unexploited say potential. Okay, so I will let the Q&A session officially start. We have already a couple of questions from the previous presentation, so I will like to speed up a little bit. As I wrote in the chat, I will let the webinar last just 10 minutes more, just to allow debate because of the technical problem. So we have a first question from Bruno Van Slambroek. I hope to pronounce well the surname. Is Turboden planning to develop reversible ORC HP units for using within power to heat to power? I don't know if the question is clear.
Yeah, and understood the question. No, at the moment we are not thinking about that. I'm not sure it's easily viable, but might be something to think about for the future.
Okay. I know that there is also Zoran Stajic. I would like to pose a question. So if you want to switch on your mic, Zoran, the floor is yours, and you can ask your question to Andrea.
Thank you. I hope you hear me.
Yes.
Yeah, we can hear you very well.
Perfect. I'm interested in more details about large heat pump details. Means could the presenter from Turboboden tell us about type of heat pump, about type of compressor, which refrigerant is in? Because I saw the example with furnace with the COP of 9.5. This is COP I never saw in my life. If it is just heating without cooling and some of that two COPs, having the COP of 9.5 on heating with 120 C, it's fantastic. So could he tell us more about it?
Yeah. So first of all, thank you for the question, which is interesting and gives me the possibility to explain more about the heat pumps. So basically the COP of the heat pump largely depends on the lift, so on the difference in temperature between the cold source and the heat user. And in that example where you see that the COP is more than 9, this lift is quite limited because we are using water at, if I remember well, now I don't have the data in front of me, but 50 to 60 degrees C, and we are lifting it to 90 to 100. So it's a very limited lift, which allows to have a high COP. Nevertheless, of course, the optimal design of the plant is crucial in order to have the highest efficiency. So you need to define the proper thermodynamic cycle and configuration of the pump. You need, as you said, to select the proper refrigerant, and the mix of these choices and of the ability to design the system allows you to have high efficiency. Specifically for the refrigerant, going to your question specifically, we are using a variety of fluids, but for the heat pumps mainly we are considering refrigerants like the traditional ones, and also as an alternative hydrocarbons, which are not so common in heat pumps, or let's say probably we are one of the few companies using those, but that's coming from our long experience in the ORC systems where hydrocarbons are the typical fluids. And hydrocarbons allow to handle high lifts with good efficiency. In terms of type of compressor, we are using a centrifugal compressor of our design, optimized for the specific application.
Okay, thank you. I know that, Andrea, you have a question for Lorenzo, so please.
Yes, thank you. Now, my question was about I was looking at the presentation and I saw that there is a significant potential of exploiting the waste heat from industrial processes to feed the district heatings, which is, of course, quite interesting for us because our technology could fit into that. So given that in Italy there are already some incentives like the white certificates, I was wondering what are the other barriers that are not basically allowing this plant to be undertaken in a larger number than what is happening today.
But the main point is, first of all, there is not a specific support scheme for district heating networks expansion. We had up to 2015, and it was based on white certificates, but it was modified and it is no longer useful for development of the networks. And this is the main issue, because we need to invest in networks to connect the sources of heat to the cities and to the demand. This is the first. Second, there are some forms of white certificates for the producers. I mean, for the producers, they can have access to this, but it is this access is customized. Every single project has to be approved by the authorities, by GSE in particular, and they have very, very strict rules, and there is a quite big uncertainty in getting the incentives. So, and you know, uncertainty is not a friend. Is not a friend of big investment.
Yes, yes. Thank you. Very clear.
Absolutely. So Paolo Leoni raised his hand. So please, Paolo, if you have a question.
Hi, thank you. Yes, Paolo from AIT, Austrian Institute of Technology, but I am Italian. I have a question, in more technical question. We are talking in general in this webinar of DHC, district heating and cooling, but I'm figuring out that most of the observations are about district heating, if not all. So my question is what is the status, and what can we assess as a future of district cooling in Italy? And also based on the fact that while district heating more in center and North Italy, demand is, although this is not completely right, because in the south also there are some cold mountain regions, but the district cooling is requested. So the cooling for office or for apartments is mainly is requested throughout Italy, we'll say.
Yes, I try to answer. So thank you for the question. Today I presented the results of the study in a very aggregate form, but in reality the universities are writing the final report, and the final report will be very detailed on single municipalities in Italy. So we will be able to look to the district heating potential in every single municipalities. And if you look to these details, you see that there is a significant potential also in the southern, in some of the southern and central areas. For example, you can see that the main potential is around Rome, because Rome has a very high population and a very high availability of geothermal heat. And also you can find potential in the south, in Bari, in Taranto, in Foggia, so in other south, in some towns of the south. And of course, you can find also there is a cooling potential, not only a heating potential. Of course, the cooling demand in this moment is not the same as heat demand. It is a market that has to be increased. But the availability of waste heat also during summertime can provide the possibility to realize solutions also for district cooling. But in any case, in the final report of the study that will be presented in a short time, you can find also this information.
Thank you very much for the explanation.
Okay, so the time I would say is run out. I would like to pose, I would say, a short question to both of the panelists, just to conclude, to have a few final words. So the COVID-19 crisis, we know that there is a motto like saying never waste a good crisis. So Green Deal, Recovery Fund, and so on. From the policy and technological side, how we can, I would say, try to exploit the most from this crisis, which are the opportunities that we cannot miss to turn this emergency in a good, I would say, boost and support for the district heating networks, for the point of view of technical innovation and from the point of view of policy. So I don't know, Lorenzo, Andrea, if you want to say few last words, and we can conclude.
Yeah, maybe I can start with my answer. Yes, definitely, I agree with you. This is I mean, very bad situation. Of course, it's a huge tragedy, but it's also bringing with it some big opportunities for the future. And the first big opportunity is to rethink the future. So the content of this webinar goes exactly in that direction. So the future, we should make it different from what the past was. And by a technological standpoint, I think we have a huge opportunity because, as you said, there are a considerable amount of funds that are made available for new projects, especially involving innovation in the area of clean technology. And so as a technological provider, we have to develop more and more cutting edge technologies that could be suitable for possible projects for our users and customers. And the funds are available, so the technology must be available, and this is our role. So the task is on our shoulders. And then, of course, there is the part of the investors and the developers that have to be in the condition to develop new projects and sustainable projects.
Yes, just a few words from my side. Yes, COVID crisis is a very tough situation. Italian government took some measures for restrictions also in the last days. We have been riots during the last night in several cities in Italy. People against these restrictions. Because there is an economical problem, because the economy, because the people are losing their jobs. And so our sector has the possibility to restart in some way the economical engine. Because when we talk about investment, we talk about jobs, we talk about the restart of this economical engine. So it's very important that we don't miss this opportunity, and that our policymakers will take this opportunity to create the condition. Because of course we talk about some support schemes, but the support scheme is the element that can start also a lot of investments from operators. So it's a mix of private investment and the support scheme. We have to create the condition for this.
Thank you. Thank you. We all hope that this will come and end quite quickly and we can restart everything better than before. So thank you for participating in this webinar. Thank you for being still here despite all technical problems. And the recording will be available on the Euratom Power YouTube channel. The chat will be still open, so you can ask questions on this chat. So yeah, thank you, and see you soon for the next Euratom Power webinar. Have a great rest of the day. Bye-bye.
Thank you. Thank you all. Thank you very much.
Bye-bye.
Bye-bye.